Hello everyone, I trust you are all as well as can be. Welcome to Frontline Systems webinar on data mining using the power of Analytic Solver plus RASON. I am Dr. Sima Maliki and I would like to thank you for joining us in this virtual gathering to briefly talk about and share some of the possibilities that Frontline Systems software offers to train and evaluate your machine learning models and create multi-stage workflows and easily deploy them as cloud services. You are welcome to email your questions to consulting@solver.com. I look forward to hearing from you. Today we start with a brief overview of Analytic Solver Desktop and then Analytic Solver Cloud, which will allow you to use all the advanced analytic capabilities from the convenience of your browser anywhere. As we review the ribbon, I will show you some examples, starting with the time series example and then finding the best supervised machine learning algorithm for a healthcare application. Then we practice creating multi-step data science workflows, which allows you to combine various data mining techniques and as easy as dragging and dropping icons for each step to train and compare multiple algorithms. After that, we show you how, with only a few clicks, you can deploy your machine learning workflows to the Azure cloud to run it as a cloud service using Analytic Solver plus RASON. RASON is our cloud platform for model deployment. So if you want to gain the real business value, you need to get the results of your models into the hands of people who need to use those results and doing so in an ongoing basis. This could be people in operations, sales, customer service, manufacturing, in a form that they can easily ensure that it is up to date, it has up-to-date data. They can rerun the model's data mining process, either view the results or plug them into another software application or process. So this is what we call model deployment. So we will talk a little about how to make your model results available to people using a web application with embedding your data mining workflow and creating your own web page. Two key components to our product line are Analytic Solver, our authoring tool, working either in desktop Excel or Excel for the web, and then RASON. RASON, our decision management platform, almost always used from a web as a cloud-hosted, Azure-hosted system that offers a REST API. So what is pictured here is RASON.com. RASON.com is a front-end portal to the RASON REST API that allows you to do a lot of things, including building and solving not only simple models, simple optimization, simulation, or data mining models, but multi-stage flows where data and model results can flow from one stage to another. Just try reverse compared to Analytic Solver can be used to create and test models all by itself, but the good news is that it is possible to deploy models to the cloud to RASON entirely within Excel and even check runs of your models without leaving an Excel, and we will talk more about that. Now, let's open Analytic Solver for a quick overview of Ribbon. This is the most recent version of Analytic Solver that was released on July 30th. Let's walk through the tabs. This is the ribbon you can use to apply the full power of data exploration, visualization, and predictive analytics. We will also touch on Analytic Solver, the deploy model group here, the deploy model icon. Let's walk through the ribbon from left to right. Clicking on the Model tab displays or hides the task pane. Then you have Get Data that allows you to bring in a statistically representative sample of your data into Excel. This could be another worksheet, different databases. You can bring text data using file folder And also you can connect to our big data Apache Spark clusters, get a sample or summarize. Next group is data analysis. First option is explore. In the explore drop-down, you can visualize your data. It also provides you with feature selection, and you can view your existing charts. So Chart Wizard allows you to create 8 different types of charts, from simple bar and line charts to scatter plots and to more complex scatter plot matrices and parallel coordinate. Our products work very well with Tableau and Power BI, so you can export your data to get more advanced visualization if you're interested. Then you have transform. These are all the data handling utilities to clean your data. Missing data handling, binning continuous data, categorical data, and also principal components available here. Then you have cluster analysis and text mining, allowing you to gain insight from your unstructured text data. Next group is the time series group. So we have partition, ARIMA, and a smoothing. Let's spend a few minutes here. Time series is a set of observations on a quantitative variable collected at equal time intervals. So every observation has a date and time on it, and there are usually equally spaced intervals. I'm going to show you an example right now. So to do that, I'm going to click on Help on the ribbon, and let's click on Example Models, and then Forecasting Data Mining Examples. I'm going to open Air Passenger Dataset. Let's go back to Data Mining ribbon. So this data set contains the monthly totals of international airline passengers from 1949 to 1960. So as you can see, we have only time variable, this is the months, and also a quantitative variable, number of passengers that it's collected over time, basically each month. Other examples are stock prices, exchange rates, consumer price index, or unemployment rate. These are all other examples of time series. So it is always useful to use the chart wizard to gain some insight. So let's select a cell within the data and click on Explore Chart Wizard. For this example, I'm going to use line chart and click on Next. Now we have to choose passengers for our variables, and then click on Next and use month for x-axis and click on Finish. Here are the results. As it can be seen here, this figure suggests that the data is non-stationary. It has a strong upward trend. It also has a seasonal pattern. So you can gain some insight from your data right now. On the top corner, there's an option to color if you have a categorical variable. Here we don't have any categorical variable. You have some filters to the right. And also you could select a part of chart and then look to the right for information about individual records. Or here observation. So this is observation 31 out of 144. Okay, let's close this chart. You have an option to save it. If you save it, you can give it a name chart 1 and click on save. And as I mentioned before, you can go to explore on the ribbon, existing chart, chart 1. Now let's look at partition on the time series group. As you can see on the ribbon, there's a partition on in the time series group, and there's a partition on data mining group. Let's talk more about that. Since here rows are ordered by time, we cannot take random samples of time series data. So we cut it horizontally, draw a line somewhere in the data, and take one part as our training and one part as our validation. So let's practice this. Click on select a cell within the data, click on partition. Time variable is months, passenger is variable in the partition data. 60% training and 40% validation. We can accept the default setting and click OK. Here is the partition data. So in the time series, we are trying to predict forward in time to the next row or several steps forward in time. We predict next value from previous values, which is called time series forecasting, and it is available here. We have ARIMA methods with lag analysis, and we also have smoothing techniques. For illustration purposes, I'm going to show you the Holt filter. So select the cell within the partition data, go to smoothing, Holt filter, and we learned that we have a strong upward trend and we also have a seasonal pattern. So the best method would be multiplicative. You could also look at additive or no trend method and you will see the error values are much higher. So let's choose that. In this dialog, you have to decide what is time variable. Pretty straightforward. Month is time variable. Passengers is the selected variable. We have 12 periods. So this is seasonality here happens every 12 months. So we enter 12 for period. So we have number of complete season. It's 7. Okay. And we have different parameters. We have alpha, beta, and much more. So you can keep the default or you have the option to optimize the parameters or weights. Here they are called weights. And we can produce forecast on validation. Let's click OK to get the results. So these are the time plots for actual versus, this is the training data set, okay? This is the data set that was used to fit the model. But usefulness of model in forecasting will depend on how close the actual and forecasted values are in the time plot of validation set. So let's look at the chart on the left. And you can see that the multiplicative model captures the data very well, and forecasted and actual values in the time plot of validation match up fairly well. So our model is a good fit to data, but this is visually. So let's close the time plots, and for training data, obviously this is a pretty good fit. But let's look at different error measures that are available for training and validation data set, and these are some forecasts. Okay, let's continue on the ribbon. So this was our example for time series, and next we're going to look at the data mining group. Then we have partition option. So for data mining, we have the standard partition and partition with oversampling. You also can use the partition on the fly option that is available during each of the algorithms. Now, imagine you have a data mining project. You want to predict the fair market value for a house. You want to know how many units of your product a customer will purchase in the future. You want to find out if an online transaction is fraudulent or not, or if an insurance applicant is a high, medium, or low risk. In all of these scenarios, the goal is to predict an outcome based on a set of features. Price of a house, units that customer will purchase. So you can use supervised learning algorithms. Supervised learning algorithms include classification and prediction methods. So as you can see on the ribbon, we have all these classification algorithms. Classify enables you to predict a discrete categorical outcome. For example, you're predicting if an insurance applicant is a high, medium, or low risk. Okay, so we have different options from discriminant analysis to logistic regression, k-nearest neighbors, all the way to neural networks, ensembles of these methods. And on the top, you have the 5 best model option. Under predict, you also have find best model option, linear regression, all the way to regression tree and neural networks. So 10 supervised learning techniques, including 6 classification, 4 prediction models and ensembles of these models. Using these tools, you can train or fit your data to a wide range of statistical and machine learning models, classification, regression trees, neural networks, and much more, okay? So you can either sit them manually, try and find out what is the best algorithm that fit your data, or you can use this option that is available to you to use the find best model option. Analytic Solver will find out the model that best fits your data. So it validates and compares multiple machine learning models and their parameters according to a criteria that you will choose and finds the best model that fits your data, okay? You can appreciate the importance of such tool in reaching a precise prediction of, for example, mortality risk for patients and how that can influence healthcare and hospital resource allocation, leading to an improvement in healthcare services. This is just one of the examples. So I'm going to show you a medical data set. So let's click on help. I'm going to practice using the find best model for classification. So let's click on help, go to example models, forecasting data mining examples, and then let's look at heart failure clinical records. Let's click on data mining ribbon. This medical dataset contains 13 variables describing 299 patients experiencing, unfortunately, heart failure. The goal is to fit the best model to the dataset and then use this fitted model to determine if a new patient is at risk of perishing due to heart failure using the score option. So we are going to use find best model option and select all possible supervised learning algorithms and find out and observe which method provides the best fit to the data. Here we are predicting risk of mortality according to variables that include patient demographics and some underlying diseases and medical and laboratory results. So you have age, anemia, whether they have diabetes, what is the sex, female, male, do they smoke, and what has happened to them. So we are going to use the fitted model and score our new data, which is about a patient, and we want to find out if this patient is at risk of perishing due to heart failure, given this information that we know about the patient, okay? To do that, let's select a cell within the data. Let's click on classify. I will show you the partition option on the fly. Click on classify, find best model. Here's the first dialog. So we have to separate variables whether they are according to whether they are continuous or categorical, okay? And age, of course, is continuous. Anemia is categorical. This one is continuous. Diabetes is categorical. This one, continuous. High blood pressure, categorical. Let me move it here. Platelet selected. Serum creatinine, continuous. This is continuous. Sex is categorical. Smoking is categorical. Time is continuous. This event is our output variable. Okay, so last variable is our output variable. As soon as I select that, you can see the number of classes is 2 and success probability cutoff is 0.5. Let's leave the default values and click on next. to move to parameters dialog. So in the pre-processing group, we have partitioning. So let's check on partition data. You can see partitioning is available. I'm going to check partition data, accept 60% for training and 40% for validation, and click on done. You have the option to rescale data. I'm going to just activate it so you can see 4 different methods are available. We don't need to do that for this data set. You have find best model fitting options. You can select what kind of learners do you want to use. So based on the data that we have, we can use logistic regression, decision tree, neural network, and also we are performing boosting algorithms. 3 different methods are available: bagging, boosting, and random trees, which is the ensembles of decision tree. And for an example, I just want to show you for each of the learners, you can select parameters, okay? For example, for decision tree, you can decide the number of tree levels, nodes, prune the tree to choose the tree for scoring. Then you can also look at advanced or prior probabilities. You have, these are the 3 different options. If you choose empirical, Analytic Solver data mining will assume that probability of encountering a particular class in dataset is the same as the frequency with which it occurs in the training data. If you choose uniform, Analytic Solver will assume that all classes occur with equal probability, and then with manual, of course, you can manually enter. Okay, so let's accept the default setting and continue to scoring option. So for a scoring option, this is where you can determine how well each classification method fits the data, okay? And you can change the metric for scoring. Different metrics are available. You have accuracy. This is the ability of classifier to predict the class label correctly. So you have accuracy, this is the default setting. This is the ability of classifier to predict the class label correctly. You have all other metrics that are available. And you have, for example, sensitivity. And this is the proportion of positive cases that they were classified correctly as positive, okay? And then you have precision, which is the proportion of positive results that are truly positive. And then for F1 and other ones, you can refer to user guide. There's more information that's available. So let's just accept the default for accuracy. And then based on partition, you're going to do that based on validation data set, okay? And let's click on next to go to next dialog. Here we are going to perform a scoring and score training data. I'm just going to stick with summary report for training and validation and score new data that is in worksheet, okay? So let's see if the correct data worksheet has been selected. The data sort is new data. And we have to basically select the correct. Let me move that to, let's do this again. So let's select the data set. So let's choose match by name and then click on finish to run the algorithms. And here are the results. Anytime you run one of our algorithms, you will have access to Output Navigator that will quickly help you to navigate to different sections of report. So here are the classification details for the new data. Okay, that's for the new data. The prediction is 1. Now let's go to different inputs of models, okay? And then you can see that we see which algorithms are performed. If you scroll down, you will see the model performance for training and validation, and you see different metrics, okay? And you can see that the best model that is selected for performance over validation, according to accuracy, that was our choice, right? It was logistic regression, and the accuracy is 82.5%. Then we have the confusion matrix. The cases that were correctly and incorrectly classified. For training data, we have the validation confusion matrix, gives you the percentage of accuracy and much more. This is the new data that we talked about, and this is the PMML model. This is the predictive model markup language. And you could also score your new data using the PMML model and a score button on the ribbon, okay? Let's continue on the ribbon with the next example. Let's continue the review of the ribbon. So we talked about classification. We also have prediction algorithms. We also have association rules as part of the unsupervised learning algorithms that are available in Analytic Solver data mining. So we have the clustering methods, okay, and the principal component available here, and also the association rules. From you have the score on the ribbon, okay, you can score new data. So basically very similarly, click on a score, you have to choose the correct worksheet, new data, and then you match the variables with the PMML model and then get the results similarly to what we received, okay? Now on the right side in the task pane, we have the model tabs, and what really matters for us today is workflow, okay? So workflow tab allows the combination of all available data mining techniques into an executable workflow. So now is a very good time to practice and create a workflow together and compare multiple algorithms, okay? And we go forward from that. So for that purpose, we are going to open a new data set. Again, click on help. Few more things that I want to share with you regarding help is that you have access to user guides, so you can access Analytic Solver user guide. And for data mining information, you can access data mining user guide and data mining reference guide. Let's close that. We are going to access example models, but before that, click on education and training, and here you can have access to Solver academic courses, which are advanced courses on optimization, simulation, and data mining using our products. Okay, let's go back to get help. Click on example models, forecasting data mining examples, and we are going to use a different data set called wine data set. Here is our wine data set. Let's click on data mining ribbon. So this data set has information about wine, including 13 variables that describe different properties of wine from 3 different vineyards. Our goal is to assign a wine classification to each record. And we want to build a classifier model which will automatically look at this data and feed a model to indicate which vineyard the wine comes from. So my goal is to show you how you can compare multiple algorithms together. So let's use the workflow tab. And there are 2 ways to work and create workflows. One is manual and one is automatic or by recording, okay? Manual and then recording. So by recording means when you are performing different algorithms, just click on recording and it will actually create the workflow for you. I'm going to show you the manual option, okay? So goal is to compare classification tree, okay? And then compare it with ensemble methods. So we can talk more about ensemble algorithms and why they are beneficial. Let's think about this. So the first step is, where is my data? So let's click on get data, click on new, drag and drop it right here. This is our source data. So I just dragged the icon and dropped it there. Okay, and now this dialog will open. You can just click OK. Is this the right data set? Yes, define the workbook and click OK. Source data. Next, what do we want to do? I want to partition the data set and use the partition for all the algorithms, similar partition, okay? So let's find the partitioning. This is a standard partition, drag it and drop it here. So use the wine dataset, select all the variables in this dataset for partitioning purposes. Let's click and move them to the right, 60% training and 40% validation. Click OK, and you can see that immediately they connect, okay? The workflow will update and connect the source data to standard partition. Now, let's start with the classification algorithm. I'm going to drag and drop the classification tree. Make sure the worksheet represents the standard partition in the data sort selection. So let's change this to steady partition. And then you have to choose what is your output variable. It's the wine type of the vineyard. And then all remaining variables are continuous. This is easier. They move all to selected variable group. Number classes is 3. We have 3 different vineyards. So let's click on next. You can see that the partition data option is unchecked, so you cannot partition anymore. The data is already partitioned, and Analytic Solver Data Mining recognizes that. You can prune the tree. You can show feature importance. You can choose the tree to display. Let me show you the fully grown tree and click on finish. And you can see that immediately the workflow gets updated and connects the standard partition to classification tree. Next, I want to compare this with an ensemble method, and the ensemble method for classification is random tree. So let's choose random tree. Let's select the variables. Type is our output variable, and all remaining variables go to selected variable. Let's click on next or parameters tab, and you can see there's an option for number of weak learners. I can increment the number to 20, for example. This will tell Analytic Solver Data Mining to construct 20 different classification trees during the run, train each one on different subsets of data, and combine the results to get a better classification. Okay, and then there's number of randomly selected. Let's change it to 7. Show weak learner models, show feature importance, fine, and let's click on finish. And workflow again gets updated. There is an option to kind of sort the workflow or organize it in a better shape. So let's click on this button, and which called format workflow. Okay, formatting the workflow. There is no limit to the number of workflows appearing in the workflow window. You can run several different classification or regression algorithms at the same time. Okay, so they can just run parallelly to each other. Okay. So now we are ready to actually execute the workflow by clicking on the execute workflow option on this workflow tab. So this is the green arrow. Let's click on that to get the results. So let's look at the results for this is the feature importance. Okay, feature importance results, and here are the 20 different random trees that were constructed on different subsets of data. Okay. This is the PMML model. This is the classification tree output. Okay. This is the fully grown tree. So the first decision node is proline. And if you look to the right, go to the right, if proline level for that wine sample is greater than 730, check total phenol. And then if total phenol is greater than 2.05, we know that sample belongs to vineyard A. Okay, and the model results are available in the format of a tree. This is the confusion matrix, okay, for training data. For a single classification tree, you can see the error is 0. This is the confusion matrix for validation data, and you can see that there are a total of 10 cases misclassified, resulting in error of 14%. So this is for a single classification tree or 1 week learner. Now let's compare the results with those from the ensemble methods. Okay, random tree classification, these are the results. Okay, so you can look at feature importance. We already looked at the random tree models. So let's look at the training. Error is 0, of course, and let's look at validation. And you can see that number of misclassified cases reduced to 5, and error has been reduced from 14% to 7%, almost half. Okay, and you can see that ensemble methods are helpful and usually resulting better performance than a single tree. Now that we reviewed how to build a multi-stage data mining workflow in Excel, Now we can move along into deployment, sharing the results using the deploy model icon and analytic solver to deploy the data mining workflow to a RASON server on Azure. Okay, so let's click on deploy model icon. On the top, there's an option called Deployment Wizard. If you are not sure where to start or what you need, you can always use the Deployment Wizard to help you guide you through the Create App menu option. Okay, so let me click on that to show you what would happen. And you can click on Next, and it will help you guide you through the steps to choose the best option that would help you achieve your goals. For example, you want to run your model in a Tableau dashboard, or you want to run the model on a desktop or server PC or as part of a custom Windows application. Okay, so Deployment Wizard walks you through the steps of deployments that are available to you. Let's go back. When it comes to optimization and simulation, you can choose whether you want to export the Excel workbook or Cloud Ser as a Excel workbook itself, or use a RASON translation model or translation of the model. But good news is when it comes to data mining workflows, is pretty straightforward. Just click on Cloud Service and then click on RASON model. There is another option called fitted model, and as time allows, I will come back to discuss that with you. So Cloud Service, RASON model, okay? We are going to give a model a name. I'm just going to accept the default name wine, and then your workbook can reside on OneDrive, okay? You can appreciate that, and then click on save. As soon as I click on save, multiple things happen. Immediately, a browser opens and displays the workflow in a diagram editor in the format of a diagram. This is also called a decision flow, okay, but this is in a graphical form. This page is called graphical diagram editor of RASON, okay? So this is rason.com. During this time, okay, our multi-step data mining workflow was automatically translated to its equivalent expression in the RASON modeling language. The workflow was posted to RASON server, and we just used our data mining workflow as a RESTful service, okay? And this is rason.com, and you might ask, there's no code here. So let's look to the right here. There's a button here, and you can click on Show RASON Code, and it converts and shows you the code, the RASON language code. So you can see the decision flow. So that workflow from Excel is now called a decision flow, and you can see it in code. Everything was automatically translated for you in RASON language, which is called JavaScript with JavaScript object notation. And also you can see it in a graphical form. So let's click on that button and then go back and forth. You can go back and forth from diagram editor to the flow, to the code. Let's learn more about this rason.com. Okay, so this is the web IDE editor page, and then you can switch back to the RASON model editor. Okay, so this is the editor page, and here we are looking at RASON server through a front-end portal. So rason.com is the front-end portal, and in the background there's a REST API service that can be used by any application. Okay, to make it more clear, rason.com, what we can see now, this browser itself is an application. Okay, and in the backend it connects with RASON server, which is at rason.net. Okay, and rason.net exposes REST API and allows any other application to perform optimization, simulation, fit a train model, invoke a train model, fit a machine learning, and much more. Okay. Now that we have the model, now we can look at some other options here on rason.com. Okay, we can actually run the model. We just saw how we can run the model in Excel. Now we can see that how we can run the model on RASON server and see the results back here in rason.com. Okay, so there is an output pane right down here that you can see that what kind of communication is happening with RASON server. Okay, and on the top we have the execution options. Okay, and on the left these are all the models I have under my RASON account. Okay, so I can manage them from here. In a few minutes I will show you that you can access all of the models from Excel itself. So let's go to post and then click on solve to solve this data mining decision flow, and we can see load, parse, diagnose. Results are now being retrieved, and here are the results. Of course, this is a table you have to choose. This is the random tree models, and you can see that all the confusion matrix, everything is available. This is in OData format, okay, but you can switch and get the results in JSON format. So in this corner, you can see that you can show the JSON JavaScript object rotation results, okay, everything available to you, or you can actually go back and see the results in OData. So when you solve the model on RASON server, this RASON REST API can actually give you the results back to you in two different formats, OData and JavaScript object notation or JSON. If you wish to edit your model, you can do it here directly in RASON, or you can make desired changes in Excel workflow and then redeploy it, okay? So we learned how we can solve the model on RASON server and get the results back. Now that we are here, I also want to show you, as I promised, how you can create a web application that can directly communicate with RASON server and display the results, okay? So let's click on Create App on the ribbon in rason.com and then click on Web Page. Immediately, RASON script number 11 HTML downloads here, so I can just open it. So this is our newly created web application from our data mining model. Okay, here we're calling the RASON server URL. Here you can upload another RASON model. If you have a data, you have to upload it here. We in fact have a data. It's a wine data set. So let's actually upload the data. And down here you have the model in JSON syntax. There is a query parameter. This is a decision flow, so I'm going to delete that. And then you have different endpoints that you can connect with RASON server. And for example, click on solve. So from this web page, we can click on solve. You can see that we are checking the status. And as soon as it's completed, we get the results down here on this web page, okay? So basically, this is a single standalone HTML web page that uses simple JavaScript. It uses HTML to define these edit fields and buttons, but it uses JavaScript to run the entire flow by making REST API calls to the RASON server. Okay, everything you need to run the entire data mining decision flow on this single page. Okay, so if you want to learn more, you can right click and actually look at the view page source. You can see all the code that's available to you, some comments for helping you with your dev team or development team. And this helps to bypass months of development by creating a web application that solves the machine learning model on RASON server by just a few clicks. You can see that the whole data mining model is embedded. We're passing it here, and we make different JavaScript calls, AJAX calls to the server. And this is just an example of an application that can directly make calls to RASON REST API server and different endpoints and get the results back, okay? The template for this HTML page is shipped with our software. It actually, I think, sits in example folder. There's a file called RASON template. You can open it in a browser. You can also edit it with Notepad. So by using RASON create app, we learned an easy way to communicate with RASON REST API beyond Analytic Solver and RASON, and in fact from a web application. Okay. Okay, let's go back to Excel. This is the PMML model. This is the trained model with all the fitted parameter, and this is expressed in predictive modeling markup language. There is something you can do this with this PMML model, given that you have access to deploy model group and RASON server. Let me show you. You can actually go to deploy model. There are two options. One is to save this model because it has all the models with all the fitted parameters. You can save it on a local machine. So go to quick test and then click on fitted model. Give it a name, model name 1. Choose one of the models, one of these PMML models, because we have the random tree and classification tree, for example, city stored, and click on save. And it will save it for you. You have to give it a name. And now it is available on my local machine, the model with all the fitted parameters. So if you're working with confidential data you don't want to share, but you want to share the PMML model that someone can use to score the new data, for example, in case of the healthcare application, this is going to be very advantageous. Now, this is just for emailing and sharing on saving on your local machine. What if you can actually use this PMML on your web or mobile application? We can actually make it available on RASON server. To do that, click on deploy model, go to cloud service, and remember we talked about, I will show you an example, fitted model. Okay, cloud service fitted model. This will post the fitted model to your RASON account, and then you can share it and use it in different applications. So model name 1, fitted model. Let's do the classification tree stores and click on save, and immediately again the browser on rason.com would open up to show you what happened, a copy of what you posted to RASON server, and here's a copy of that PMML model. And you can see that we're getting a copy of it from the server. So let's go back to our slides. Let me minimize all of these things that we have. Okay. These are data mining steps. If you're interested, email me at consulting@solver.com, and I'm going happy to share these slides with you. I just wanted to show you. Okay, I want to show you this slide. Starting in Excel, we built a multi-stage data mining workflow, and then we created a web application. Okay, from that data mining workflow, I showed you in one example of creating web application. We promoted our multi-stage workflow to sit on RASON server, and then it can easily be available to all other applications. Okay, all with point and click. So we are offering you a cloud service that can serve the purpose of saving, maintaining, okay, and then running your analytic models, okay, in the cloud. And then you can see that there are various clients that can easily connect, talk to this backend server. This client could be a web browser, okay? We saw in the example, it can be Excel for the web. It can be rason.com. It can be a Power BI dashboard or a mobile application. Okay, let's go back to Excel. I just want to quickly show you one thing. So let's go back to the wine and then click on deploy model group. I forget to show you the manage model options. So manage models. And here you can click on manage models. I have to log in. Okay. This is basically going to connect to my RASON account, validates my license, and then it's going to load all the models that I've posted to RASON server. And as I mentioned, you can manage all those models from rason.com, or you can actually directly manage them from Excel. So here are all the models that are under my account on RASON server. So you can actually select the model and check different runs, and you can actually delete the model from RASON server from your account. Okay, back to our slides. Excel could make it easier to get started with analytics. Analytic Solver Desktop works greatly with Excel, and you also have access to Analytic Solver Cloud that works with Excel for the web and offers all the tools from the convenience of your browser. I actually want to show you just the ribbon on Analytic Solver Cloud, so give me 1 second. Let's go to Office 365. So this is Excel for the web. Let's open a new blank workbook. So here is the Analytic Solver ribbon. It's the cloud-based version of Analytic Solver, and you can see that exactly similar to what we saw in desktop Excel. And this is the data mining. So you can see we have explore features, all the features that we saw for time series, data mining, all available from the convenience of your browser. So the two key components to our product line are Analytic Solver, our authoring tool working either in this Excel, the desktop, or Excel for the web, and also the RASON server. So with Analytic Solver plus RASON, you can promote your models to run them on RASON cloud service and make the results available to other people. You can create and test models, deploy them to the cloud as RESTful decision services, and even get reports of recent runs of your decision services, all without leaving Excel, as I showed you. So RASON combines predictive and prescriptive analytics. It offers much more. It enables you to use the results of analytic models to derive operational decisions and actions. Okay, and it does that by supporting rules, decision tables, and allows you to expose analytic model results either as JSON or through OData inputs, which are always generated, and some of them can be directly consumed by a lot of software directly. This platform works very well with Microsoft Tech Stack, Excel, Power BI, Power Apps, Power Automate, and Teams. You can build your own web or mobile applications using Power App or Power Automate. You can even go further, embed your Excel workbook in a multi-stage decision flow that can combine SQL, RASON, Excel, and DMN models, passing results from one stage to another. Here is a screen showing the multi-stage decision flow in RASON, and the diagram editor can be used as a drag and drop tool as well to create multi-stage decision flow, and we also offer automatic scheduling. You are always welcome to contact me at consulting@solver.com. I really enjoyed presenting this webinar, and I trust it was helpful to you. Again, we appreciate your time. Thank you again. Until next time. Bye.